As far as graphs of polynomials go, we can identify what they look like fairly quickly. And it all comes from this first term. This is the only thing that matters when it comes to its overall shape. We can determine the number of turns that it has by looking at its degree. Since this polynomial is a third degree polynomial, it has at most 2 turns. So the number of turns is 1 less than its degree. The end behavior is determined by the leading coefficient. And all we care about, not what the number is, but whether it's positive or negative. And since in this case, the leading coefficient is positive, we say as x approaches infinity, y is going to approach infinity as well. Because 3 is positive, this infinity is also positive. Putting these two things together, we can come up with its most likely shape. The end behavior means on the right end, is it going to go up or down? Since y is going to approach positive infinity, that means it's going to go up. And since it has 2 turns, we just have to draw in 2 turns. Here's 1 turn, and there's another turn. That means that y is going to look something like this. So again, now when y is equal to negative x squared plus 45x plus 70, again, we're going to look to this leading term. Since it has a second degree, that means it's going to have 1 less than that for its number of turns. If the power is 2, it's going to have at most 1 turn. The end behavior, as x approaches infinity, we want to see if y is going to approach positive or negative infinity. And that's determined by the leading coefficient. And since this is a negative x squared, that means its leading coefficient is negative 1, and y is going to approach negative infinity. Because y is approaching negative infinity, that means it's going down on the right side. Since there is only 1 turn, that's all we have to draw in, is just 1 turn. So the most likely shape is something like this, a parabola opening down. Finally, we have this this polynomial equation that looks so simple it maybe is confusing, but again, we resort to that leading term, this x to the 4th. The number of turns is determined by its degree. This is a 4th degree polynomial, so it will have at most 3 turns. The end behavior, as x approaches infinity, we wanted to determine what happens to y, whether it approaches positive infinity or negative infinity. And going back to the leading term, the leading coefficient is a positive 1. That means y is going to approach positive infinity. Graphically, y approaching positive infinity means that that the graph is going to go up. Since there are 3 turns, we have to draw in 3 turns. Here's 1, here's 2, and there's 3. So the most likely shape for this polynomial will be something like this.